Alright guys, so I'm just going to take a few minutes to go through some of the homework problems from out of section 1-3. So we put it to a vote between period 4 and period 11 today, and the problems that we're going to end up taking a look at over the next several minutes are going to be 31, 40, 42, and 50. So we'll start with 31, and in 31 it's a regular run-of-the-mill limit problem, and what we hope happens is if we take the value that, in this case it's h is our variable, if we take the value h is approaching, which is a 0, and we put it in place of all of our h's, we hope that we get lucky enough to get a value that's not in a determinate form, a value that we're okay with. And if you put 0 here, you have 0 in the numerator. If 0 goes in place of these h's, you're left with square root of 3 as the first term in the denominator, and if a 0 goes there, it's square root of 3 as the second term. Square root of 3 minus square root of 3 is 0. Now that is one of our indeterminate forms. Anytime this happens, what you're going to want to do is anything algebraically that might help you get to the point where something cancels. And 90% of the time, whenever it's a function that involves a radical, as this one does, we're going to want to try to multiply by the conjugate of that radical expression in order to hopefully see some stuff cancel. So I'm going to take this expression, just recopying the limit here. So I'm not changing anything yet. But what I'm going to attempt to do is I'm going to attempt to multiply by the conjugate of this denominator. So I'm going to multiply by 1 in the form of square root of h squared plus h plus 3, plus square root of h plus 3. Right? Conjugates are the same two pieces, just the sign in between switched. And I need to multiply by 1 in the form of that radical expression over the same radical expressions. Just let me take a minute to get caught up and get that same thing into the numerator. And so what I'm going to attempt to do is I am going to FOIL together my two denominators. So I'm going to multiply this basically binomial, two great big terms, times this binomial with the two great big terms. Now, when I do first times first, I notice that it's this radical times the exact same radical. So that's essentially just this radical expression squared. And whenever I square a radical, the square root's gone. So for first times first, I'm just going to be left with h squared plus h plus 3. Now, I'm just going to put the grouping symbols there just to kind of show that that whole entire expression was first times first. Now, if I do outer times outer, notice I'm going to get this root times the other root, and my answer is going to be positive. If I do inner times inner, I'm going to have this root times the other root, but my answer is going to be negative. The nice thing about multiplying a pair of conjugates is every time you do, outer and inner from FOIL, they're going to cancel with each other. So those are gone. We do have to worry about last times last. And you have to be careful with this. Notice we have a negative times a positive, so our answer down here is going to be negative. If I take this root times that same root, it's that root squared, square root's going to be out of there, I'm going to be left with h plus 3. The one thing I have to be careful of is that I'm making that whole entire h plus 3 negative. The numerator I'm not going to really touch, because I'm just going to copy the numerator down exactly as it is on the previous line. I'm going to have to get some grouping symbols in here in just 1 second. So there's that great big root, there's the smaller root, and I need to multiply those things by h squared. Now, I still am within a limit here, so I'm still trying to do the limit as h approaches 0. And I notice in my denominator I have quite a bit of cancellation that occurs. Plus h, if I distribute this negative in, minus h. Plus 3, if I distribute the negative into this, minus 3. So basically these cancel. I'm just left with h squared in the bottom. Now that all of this stuff is out of the way, check out what else can happen. I have this h squared. Now that parenthesis isn't really doing anything there. I just had it there previously to show that that was my result for first times first. But my denominator is just an h squared. Notice how I have h squared times this great big thing in the numerator. I'm going to go ahead and cancel these h squareds, Because I realize if I put a 0 here and a 0 here without canceling, I'm still going to have 0 over 0. But if I get rid of those h squareds like I just did, now there's nothing left in the denominator. The denominator is a 1. And if I put 0 in place of the h's that remain in the numerator, I'll end up with a square root of 3 from this piece. And if I put a 0 in place of that h, I'll end up with a square root of 3 from the second piece. And if I have square root of 3 plus square root of 3, I have 2 square root of 3 total. So that one was a trickier problem from out of section 1.3, but you're going to want to try to do something algebraically when this pops up that hopefully allows you to get to the point where some stuff cancels. When radicals are involved, most of the time it's going to be using conjugates that will get you past the indeterminate form. I'm going to stop this video and I'm going to do a separate video for 40 and 42 and then a third video for number 50.